In this video, we're going to focus on how to graph conic sections like ellipses, parabolas, hyperbolas, and also circles as well. And in addition to that, we're going to talk about how to look at equation and to tell if it's going to be a circle, ellipse, parabola, and hyperbola, and how to put it in standard form. So let's focus on the graphing part. Let's say if we have this equation, x squared plus y squared equals 9. And this is a circle, but how can we graph this circle? So the standard equation for a circle is it's x minus h squared plus y minus k squared is equal to r squared. The center of the circle is h comma k, but there's no h and k in this problem, so the center is based on the origin. It's 0, 0. Now r squared is basically 9. So if r squared is equal to 9, if you take the square root of both sides, you'll see that the radius is 3. So starting from the origin, which is 0, 0, you need to go 3 to the right, 3 to the left, up 3, and then down 3. And then draw a circle connecting those points. So that's how you can graph that particular circle or that equation. Let's try another example. So let's say if we have this equation, x minus 3 squared plus y minus 4 squared. Actually, let's say y plus 4 squared equals 16. So we need to find h and k. So the center is basically, if you set x minus 3 equal to 0 and you solve for x, you'll get 3. So h is 3. So basically you change the negative 3 to a positive 3. And the same thing with the 4. You change the positive 4 into a negative 4. So the center is 3, negative 4. And since r squared is equal to 16, the radius of the circle is 4. And then we just have to graph it. So we need to go 3 units to the right and down 4 units. So here's the center. It's at 3, negative 4. Now, because the radius is 4, we need to go 4 units to the left, which will give us this point. 4 units to the right, and then up 4 units, and then down 4 units. And so that's the circle. Let's try one more example. So let's say if we have this equation, x plus 2 squared plus y minus 3 squared is equal to 4. So the center is negative 2, comma 3. You change the positive 2 into a negative 2 and the negative 3 into a positive 3. And the radius is the square root of 4, so it's 2. And then plot the center. So we need to go 2 to the left, up 3. So it's over here. And the radius is 2, so we need to go down 2, and then up 2, 2 to the right, and then 2 to the left. And then connect those 4 points. And so that's how you can graph circles. So now let's move on to an ellipse. An ellipse looks similar to a circle, but it's uneven. It's not equal on all sides. Let's start with this equation, x squared over 25 plus y squared over 49, and let's say that's equal to 1. Now, the general equation for an ellipse, it's x minus h squared, a squared, and then y minus k squared over b squared is equal to 1. Now, the a squared is not always under the x. A squared could be under y minus k. What you need to know to distinguish between a and b, a squared is the larger of the two. So in this case, for this problem that we have, this is actually a squared because 49 is larger than 25. 25 is actually b squared. Now we need to realize that the center is 0, 0, because if you see just x squared and y squared, if it's not like x minus 2 or y plus 3, then the center is 0, 0. So it's based on the origin. Now, since a squared is equal to 49, what this means is that a is equal to 7. And 7 is under y squared. So from the origin, we need to go 7 units up and 7 units down. The way we plot is very similar to a circle, but there's no radius. A and B are different. If A and B were the same, then it would be a circle. Now, B squared is 25. So if you take the square root of 25, that's 5. And B is under x, so we need to go 5 units to the right and 5 units to the left. And then we just connect those points. So that's how you can graph an ellipse. Now you need to know that this axis right here is called the major axis, but it's vertical, so it's the major vertical axis. This line here, because it's shorter, it is known as the minor axis, but it's horizontal. So it's the minor horizontal axis, and this one is the major vertical axis. So let's say if you get a question and they ask you for what is the major vertical axis length, how long is it? The major vertical axis, it's always equal to twice the value of A. And so in this case, I'm going to write MA for major axis. Since it's equal to 2A, it's 14. The minor axis, they're both N. The length of the minor axis is twice the value of B. So 2 times B, it's 10. By the way, the endpoints of the major axis, which is 0, 7, and 0, -7, those endpoints are known as vertices, which is the plural form of vertex. So some books will call it the major vertices, and other textbooks will call the endpoints of the minor axis like the minor vertices. If they don't use the word minor, then the vertices correspond to the endpoint of the major axis. Now the only other thing we need to find is the foci. The foci it's along the major axis, but whenever you have a graph that opens up, the foci is somewhere in the middle. So there should be a foci somewhere along this major axis, between 0 and 7. To find it, you need to use this equation. C squared is equal to A squared, not plus, but minus B squared. For a hyperbola, it's A squared plus B squared, kind of like the Pythagorean theorem, but for an ellipse, it's A squared minus B squared, because C is less than A, and I'll explain why shortly. But let's solve for C squared. We already know the value of A squared, and this is B squared, so it's 49 minus 25. And that's 24, but if you take the square root of both sides, the square root of 24, we can reduce that to root 4 and root 6. So it's 2 root 6. So the foci, the coordinates of the foci, x is 0, y is c, so it's plus or minus 2 root 6. As a decimal, 2 root 6 is about 4.89, so just under 5. So the foci should be somewhere over here and somewhere over here. So it's inside. Imagine this ellipse as like a half parabola. It's inside of it. So that's why the foci, that's why c is less than a. And so therefore it's c squared equals a squared minus b squared, because a is bigger than c. As you can see, this is the value of a, which is longer, and this is the value of c. C is the distance between the center of the ellipse and the foci. So if the origin is not 0, 0, then the coordinates of the foci will be affected. By the way, sometimes you may get a question that asks you for the x and y intercepts. For this particular example, the y-intercepts are basically the endpoints of the major axis, which is 0, 7, and 0, -7. So those are the y-intercepts. The x-intercepts are the endpoints of the minor axis. So in this case, it's plus or minus 5, comma 0. That's a nice way to write it if you don't want to write it twice. But let's try another example. So let's say if we have this problem, x minus 2 squared divided by 16 plus y plus 3 squared divided by 9. And let's say that's equal to 1. Now the first thing you need to do is find the center. So since we have x minus 2, we need to reverse it. So it's going to be plus 2. And for y plus 3, change it to minus 3. So we need to travel 2 units to the right and down 3. So that's where the center is. But keep in mind, the center is not actually on the graph. So now we need to know what's a squared and what's b squared. A squared is the larger of the two. This is a squared and this is b squared. So if a squared is 16, that means a is the square root of that, which is 4. And the square root of 9 is 3. So notice that a is under under x. So you need to travel 4 units along the x-axis. So 4 units to the right and 4 units to the left. And b is under the y variable. So and b is 3. Go up 3 units and then down 3 units. So it's not very difficult to graph an ellipse. It's finding the other details about it that you have to be careful. So let's identify what's the major axis and what's the minor axis. The major axis, is it vertical or horizontal? The major axis is wherever a is. A is along the x-axis, so the longer side is the major axis. The major axis is basically the x-coordinate of this, actually the y-coordinate, because it's horizontal. So the major axis is at y equals -3. That's the equation for it. The minor axis is wherever b is. This is the minor axis, because b was over here. So the minor axis, if you want to write that as an equation, it's x equals 2. The length of the major axis is equal to 2a, twice the value of a. And since a is 4, it's about 8 units. So this is +6, this is -2. They differ by 8 units. And the length of the minor axis, that's twice the value of b. And so b is 3, so it's 6. This is -6 here, and y is 0 at this point. So you can see this is a distance of 6. And here we have a distance of 8. Now, if you want to find the endpoints of the major axis, since you already graphed it, you can see that it's going to be -2, 3 and 6, 3. But if you wish to find it from the center, the endpoints of the major axis is basically the vertices. And it's, for this particular example, is h plus or minus a, comma k, because a is along the major axis, which is it's horizontal. So we add and subtract a to the x coordinate of the center. So basically we do 2 plus or minus 4, comma, -3. So keep in mind, h is 2, k is -3. So basically what this means is that we go 4 to the right along the x-axis and 4 to the left from the center. And so we get these 2 points. 2 plus 4 is 6, and 2 minus 4 is -2, which correlates to this point. This is 6, -3, and -2, -3. So that's the vertices, or the endpoints of the major axis. Now, if we wish to find the minor vertices, or the endpoints of the minor axis, which is right here, we can use this equation. So I'm going to put MV for like minor vertices. So it's going to be H, comma, K plus or minus B, because we added and subtracted B to the y coordinate of the center. So it's 2, comma, the y coordinate, which is -3, plus or minus the value of B, which is 3. So the two answers that we get is 2, comma, -3 plus 3 is 0. So that's basically this point right here, 2, 0. And -3 minus 3 is -6. So we get this point, 2, -6. So these are our minor vertices. Now, if you need to find the intercepts, as we can see, we have one x-intercept only in this graph, which is 2, 0. And there is a y-intercept, which is here and here. Now, we don't know exactly what those points are just by looking at this graph because this is a rough sketch. But for any equation, if you have to find the x-intercept, plug in 0 for y, and then algebraically solve for x. If you need to find the y-intercept, plug in 0 for x, and then solve for y. Now the last thing we need to do is find the foci. The foci should be somewhere along the major axis. Now those points aren't precise, but it's a rough estimate. The first thing you need to do is find the value of c. So c squared is a squared minus b squared, which is a squared is 16, b squared is 9, so that's 7. So if you take the square root of both sides, c is radical 7. So to write the coordinates of the foci, since the major axis is horizontal, you need to add and subtract c to the x coordinate of the center. So the equation for this particular graph, it's going to be h plus or minus c comma k. So let's see if I can put that here. So the foci is going to be h, which is 2, plus or minus c, which is radical 7, comma, -3. If you want, you can convert that to a decimal value, but the foci should be somewhere around here and somewhere there. As you can see, it's inside of the ellipse. So for the sake of practice, let's try one more example. Let's say if we have x plus 1 squared over 9 plus y minus 2 squared over 25. And let's say that's equal to 1. So first let's find the center. It's -1, comma 2, which is right here. And a squared, actually that's a b squared. B squared is the smaller of the two. B squared is 9, a squared is 25, since 25 is larger than 9. So that means a is 5 and b is 3. So a is under the y, so we need to go up 5 units. 1, 2, 3, 4, 5. And then down 5. 3, 4, 5. B is associated with x, so we need to go 3 units to the right. And then 3 units to the left. And then connect the outer points. So that's our ellipse. And if you want to find the foci, solve for c. So since c squared is a squared minus b squared, we know a squared is 25, b squared is 9. 25 minus 9 is 16. The square root of 16 is 4, so c is 4. So you need to go up 4 units, which is over here, and down 4 units from the center. So that's the coordinates of the foci. But to write it, this time it's not h plus or minus c, it's h comma k plus or minus c, because the major axis is vertical. The foci, the center, and the major vertices, they all pass through the major axis. So therefore the foci is h, which is -1, comma k, which is 2, plus or minus the value of c, which is 4. So 2 plus 4 is 6. That gives us this point. It's at -1, 6. And then the other one, 2 minus 4 is -2, which is over here. It's at -1, comma, well actually this one, -1, comma, -2. So those are the coordinates of the foci. So now let's find the endpoints of the vertices, or the endpoints of the major axis. So those 2 points, you can probably see it what it is graphically, but I'm going to do it this way. It's h, comma, k plus or minus a, since the major axis is vertical. So it's -1, 2 plus or minus the value of a, which was 5. So 2 plus 5 is 7, and 2 minus 5 is -3. So these are the major vertices, which are the endpoints of the major axis. Now keep in mind the length of the major axis is 2 times the value of a. So in this problem, it's 10. That's the length of the major axis. The length of the minor axis is 2 times the value of b, which is 6. So let's try an example where we have to find the x and y intercepts, just for the sake of practice. So let's say if you want to find the x-intercept, plug in 0 for y, and then solve for x. So what I would do to get rid of all the fractions is I would multiply by 9 and 25. So if you take this term and you multiply by 9 and 25, the 9's cancel. And so you get 25x plus 1 squared. -2 squared is 4. And this term times 9 and 25, the 25's cancel. So you just get 9. And then here, 1 times 9 times 25. The value of 9 quarters, that's $2.25, so we know it's $2.25. So 4 times 9 is 36, and 225 minus 36, that's 289, I believe. And then divide both sides by 25. So x plus 1 squared is 289 over 25. And then take the square root of both sides. The square root of 289, I believe that's 17. And so you get x plus 1 is equal to plus or minus 17 over the square root of 25, which is 5. So x is -1 plus or minus 17 over 5. Now if you go back to the example that we had, notice that we have 2 x-intercepts because the ellipse, it touches the x-axis twice. If you want to find a y-intercept, pretty much plug in 0 for x, solve for y, and just basically follow the example that we just did. But now let's move on to hyperbolas. So let's say if we have x squared over 9 minus y squared over 4 equal 1. The general equation of a hyperbola, it's x minus h squared over a squared minus y minus k squared over b squared equals 1. Now a is not the larger of this two this time. A squared is simply whichever comes first. You can also have the other form of this equation, which is y minus k squared over a squared minus x minus h squared over b squared equals 1. So whichever one is positive is associated with a. Whichever one is in front of the negative sign, or whichever one is negative, has the b squared. Now what you need to realize is that for a hyperbola, if x squared comes first, it opens left and right. If y squared comes first, it opens up and down. But we'll go over a few examples. So let's solve this one. The center is 0, 0 because there's no h and k for this example. So that's where the midpoint of the two vertices. Since a is 3, we need to go 3 to the left and 3 to the right. And b squared is 4, so that means b is 2. So we need to go up 2 and down 2. And then make a box. In this case, like a rectangle. And then draw 2 lines. These are the asymptotes. Make sure that these 2 lines crosses the, make sure it forms like a diagonal through the rectangle. It has to pass through the center as well. Now, these 2 points are where the graph is actually going to touch. It's going to meet at those 2 points. It doesn't touch these 2 points here. Those are imaginary points. So this graph is going to look like this. It follows the asymptote, it touches the vertex, and then it follows the other asymptote. So that's how you graph a hyperbola. These are called the vertices. Those are the vertex of the hyperbola. So the vertices are plus or minus 3, 0. The foci is somewhere here. It's always where the graph opens towards. So if the graph opens this way, the foci is like towards it. If it opens this way, the foci is over here. Now to find it, it's a little different. Instead of it's c squared equals a squared, not minus, but plus b squared. For an ellipse, it's a squared minus b squared. This time, as you can see, the value of c is larger than the value of a. So that's why c squared is a squared plus b squared. So it's going to be 9 plus 4. That's 13, so c is the square root of 13. So the foci, therefore, is plus or minus radical 13, 0. Now the only other thing that we need to do for this type of graph is we need to find the asymptotes. The equation for the asymptotes, it's y minus k is equal to, now it can be b over a or a over b, plus or minus. And then x minus h. Here's how you tell. So what we have is the asymptote is basically a line. And whenever you have a linear equation, in slope-intercept form, it's mx plus b. Notice that the letter in front of x is m, which represents a slope. So b over a is the slope of the line, which is rise over run. So from the center to this point, you need to go up b units, that's your rise, and then you run a units. So it's rise over run, b over a, for this particular example. When it opens this way, it's actually going to be a over b. But you can tell by just doing rise over run. So for this actual equation, we know that h and k are 0. So to write the asymptotes, it's going to be just y, there's no k, is equal to plus or minus the value of b, which is b is 2. B squared is 4, so b is 2. And a, if a squared is 9, a is 3. So it's y is equal to plus or minus 2/3 x. Those are the asymptotes for this particular hyperbola. So let's try another example. So let's say if we have x plus 1 squared over 25 minus y minus 2 squared over 16. So a squared is the first number. It's not the bigger or the smaller one, whichever comes first, whichever is positive. And the second one is usually negative, so that's b squared. So we know that a is 5 and b is 4. And the center is -1, +2. Just don't forget to change the signs. To find the foci, it's c squared is equal to a squared plus b squared. So a squared is 25, b squared is 16. So that's 41, so c is the square root of 41. So let's plot the center first. It's at -1, +2, so it's over here. Now, A is under the x variable, so we need to go 5 units to the left and 5 units to the right. So this coordinate is at -6, this is 4, and B is 4, so we need to go up 4 units. So that's at +6, and down 4 units to -2. And then draw the rectangle. And then draw the asymptotes. Now this is the value of A, same as here. So A is horizontal this time, just like last time. By the way, this is called the transverse axis. And the graph is going to touch at those 2 points. So it should look something like this. So the vertices, which are these 2 points, but let me write the general equation. It's h plus or minus a comma k. So h is the x coordinate of the center, and a is 5, and k is 2. So -1 plus 5, that's 4, and -1 minus 5 is -6. So this point, as we can see, it's 4, 2. Here this is 2, and this is 4, so that's 4, 2. And this one, it's at -6, 2, which is what we have. So those are the vertices of the graph. Now to find the foci, it's also along the transverse axis is horizontal, so it's going to be h, but plus or minus c, comma k. So we got to find the value of c, which we already know it to be root 41. So it's -1 plus or minus root 41, comma 2. Now we can't add -1 plus root 41, so we're just going to leave it like this. So we know the foci is somewhere over here. And it's somewhere on the outside. It's past the vertices. Now the only other thing we need to find is the asymptotes, which is y minus k is equal to plus or minus. Now rise, starting from here, we need to rise b units, because b is vertical, a is horizontal, so the run is still a, so it's b over a, rise over run, and then x minus h. So that's y minus k is -2. Actually, no, k is plus 2. So it's y minus 2 is equal to plus or minus b over a. This is b, that's a. So 4 over 5. X minus h. So h is -1. So -1, you basically get what's here. So x plus 1. So notice that what you see here is what's here, and what you see there is the same as that. But this is the equation of the asymptotes. Now the reason why we have plus and minus is because there's 2 of them. If it's plus 4 over 5, the slope is positive, so it's going up. Minus 4 over 5, the slope is negative, so it's going down. The -1 is for the one that decreases as you go from left to right. The positive one is for the one that goes up as you go from left to right. Now, for the sake of practice, we're going to try one more example. Let's try this one. X minus 2 squared. Actually, let's start with y this time. So y minus 2 squared over 4 minus x plus 3 squared over 9. And that's equal to 1. So a squared is whatever comes first, and this is b squared. So a, therefore, is the square root of 4, which is 2. b is the square root of 9, which is 3. And to find c squared is a squared plus b squared. So 4 plus 9, which is 13. So therefore c is root 13. The center is, let's look at the x value first. So it's negative 3, and the y value plus 2. So it's at negative 3 comma 2. Now, since a is 2, but it's under the y, we need to go up 2 units. And then down 2 units. So wherever the points that a give you is the vertices. So that's where the graph is going to be. So the transverse axis this time is actually vertical. Now to find, we know b is 3, so we need to go 3 units to the right, 3 units to the left, and then let's draw our rectangular box. Next, let's draw the asymptotes. So keep in mind the vertices are here. So this graph is going to open like this. It opens up and down because y is in front this time. So the foci is somewhere over here. It's up and down rather than left and right. And to find the coordinates of the foci, we need to add and subtract c to the y coordinate of the center because we went up and down. And y is associated with up and down. X is associated with left and right. So the foci is it's the center, negative 3 comma 2, but plus or minus c, or plus or minus root 13. So that's the coordinates of the foci. And for the vertices, which are basically these 2 points, it's h comma k plus or minus a. So it's negative 3, and k is 2, so 2 plus 2 is 4, and 2 minus 2 is 0. So those are the major vertices. Now the last thing we need to find is the asymptote, which is y minus k is equal to plus or minus. Okay, so we went up a units. The rise is a, the run is b. And since the slope is rise over run, it's a over b, and then x minus h. So y minus k is basically exactly what you see here. So it's y minus 2. And a is 2, b is 3, so 2/3. X minus h is basically x plus 3. And that's how you find the equation of the asymptotes. And I believe we're not missing anything. I think that's it. I think we covered everything there. So now, let's move on to our next topic. So let's focus on the parabola. The general equation for a parabola, well, before I do that, let's go over the different types. This parabola is y is equal to x squared. And if it opens downward, y is equal to negative x squared. If it opens to the right, x is equal to y squared. And when it opens to the left, x is equal to negative y squared. Now, somewhere over here, this is the directrix. And the distance between the vertex and the directrix is p. So in this case, it's y is equal to negative p. The foci is p units above the vertex. So wherever the graph is, that's where the focus. So the focus is over here. The directrix is over here. In this case, the coordinates of the focus is it's p comma 0. But for this example is 0 comma p, because you went p units up. Here you went p units to the right. For this one, the directrix is x is equal to negative p rather than y. And over here, it's y is equal to positive p. And since the focus is below the origin. The coordinates is 0, negative p. So you have to know the general shape of the graph to see where the focus is going to be, if you have to add p or subtract p. So keep in mind, for the directrix, if you have a horizontal line, it's y equals. If you have a vertical line, it's x equals. Here, it's x equals positive p, and the focus is actually negative p comma 0 this time. That's if the parabola is based on the origin. Now, let's say if it's moved away or transformed or shifted away from the origin. These are the equations that you're going to need. Y minus k squared is equal to 4p x minus h. So basically, this is the equation that's like y squared is equal to x, or x equals y squared. So this can open to the right or to the left. It opens to the right if p is positive or greater than 0. If p is negative, it opens towards the left. Now the next equation that you need, x minus h squared, is equal to 4p y minus k. So this is basically y equals x squared, which can open up or down. It opens upward if p is positive. And if p is negative, it opens downward. Alright, so let's try some practice problems. Let's start with the basics. Let's say that y squared is equal to 8x. So that means there's no h and k, so the center is 0, 0. Or at least, we really don't have a center. We should really call it the vertex. That's at 0, 0. So this is in the form y minus k squared is equal to 4p x minus h. So notice that 8 is equal to 4p. So set 4p equal to 8. If you divide both sides by 4, 8 divided by 4 is 2, so p is 2. And then we can graph it. Now it really depends on what you want to do here. I'm going to draw a smaller graph, but more like a rough sketch. Since we have y squared equal to x, or x equals y squared, we know it's going to open to the right or to the left. And since p is positive 2, we know the graph opens to the right, which means the directrix is over here. And p is 2, so the foci is over here. So the foci, it's p comma 0, or in this case 2 comma 0, since p is 2. And the directrix is x is equal to negative 2, because you got to go p units to the left. So the first thing we should do is plot the vertex. Then go p units to the right, and then p units to the left. So there's your directrix. And here's the focus. But now, how can we plot this graph accurately? What you could do is you can plug in some points. Now, it's easier if you plug in, let's see, we could make a table if you want. Should we plug in values for x or for y? Which one is easier? If you have y squared, it's easier if you plug in values for y rather than x. Let's plug in 1 for y. If you plug in 1, actually 1 is going to be too small. Let's solve for x. Y squared divided by 8 is equal to x. Let's say if we plug in 2 for y. That's 2 squared is 4, 4 over 8 is a half. If you plug in negative 2 for y, when you square it, it's still going to be positive 4, so you're going to get the same x value. Let's try a bigger number, like 4, plus or minus 4, because it's going to give us the same x value. If you plug in 4, 4 squared is 16, 16 divided by 8 is 2. The last point to plug in would be like 8 for y. 8 squared is 64, and 64 divided by 8 is 8. But we may not need to go that far. So when we plug in 2 for y, x was about 0.5. So that means it's somewhere over here. But also for negative 2, we get positive 0.5 for x. Let me use a different color. The key is to choose the right points. You want to choose points that you can get whole numbers, which 4 was the best example. When y is 4, x is 2. So that means it's over here. That's 2 comma 4 and 2 comma negative 4. So we have a very wide graph. Now let's say if we were to extend this graph. So this would be 3, 4, 5, 6, 7, 8. And let's go up along the y-axis. So 5, 6, 7, 8. And I'm out of space over here. So this is somewhere over here. It's at 8, 8. And 8, negative 8, it's, well, I'm out of space there. So this graph looks something like this. So if you want to get a very accurate graph, if that's important, make a table, plot some points. If you just want a rough sketch, you just need to know what the direction is. Because if your test is multiple choice, you don't need a table. You can pick the right ones and eliminate the wrong ones. Let's try another example. So let's say if we have y minus 2 squared is equal to 4x minus 3. So our general equation is y squared is equal to x. So this one's going to open to the right again. And we know the focus is going to be over here. The directrix is over here. So the center is 3 for x, positive 2 for y. So we need to go 3 units to the right, up 2 units. So that's the, I keep saying the center, but I meant the vertex. So now we need to find p. Whatever this number is, set it equal to 4p. So therefore p is 1. And since it opens to the right, we need to go 1 unit to the right. That gives us the focus. So the focus is basically h plus p comma k, or 3 plus 1, which is 4, and k is 2. So that's the coordinates of the focus. For the directrix, we need to go 1 unit backwards, and then we can draw a vertical line. So the directrix is that x is equal to positive 2. So now let's see if we can find some points to graph it. So we have a 4 in front. Let's say if we plug in, let's make a table. We know the center is 3, or the vertex is 3, 2. Let's plug in 4 for x. And let's see what we get for y. If we plug in 4 for x, it's going to be 4 times 4 minus 3 is 1. So we get that. And if we square root both sides, y minus 2 is equal to 2. Well, we get plus or minus 2. So y minus 2 is equal to 2, and y minus 2 is equal to negative 2. So y is equal to 4. And here, if we add 2, y is equal to 0. So that means when x is 4, y can be 0, and it can be 4. So 4, 0 is basically over here, and 4, 4 is over there. In the last example, we plugged in for y and solved for x. But in this example, I chose to solve for y instead. Now, if I choose 5 for x, it's going to be 2 times 4, which is 8, and I can't take the square root of 8. So the next value I'm going to choose for x is going to be 7. Because 7 minus 3 is 4, which is 16. And we can take the square root of 16 because that's going to give me an integer, which is 4. So y minus 2 is equal to plus or minus 4. So y minus 2 is 4. That means if you add 2, you get 6. And y minus 2 is equal to negative 4 as well. If you add 2, you get negative 2. So I kind of picked the points differently from the last example. So we need to go to 7. And at 7, it's going to go up to 6. Which is over here. And it's going to go down to negative 2. So that's enough points to get a rough sketch for this graph. And that's how it looks like. So our last example for today, let's try this one. X plus 1 squared. Let's say that's equal to 2 times y minus 3. So here we have the example where x squared is equal to y, or y is equal to x squared. And let's actually add a negative sign. So it's going to open downward. So the focus should be somewhere over here, and the directrix is horizontal this time. So let's find a center. It's negative 1 comma 3. So 1 to the left, up 3. And I actually mean the vertex. I keep calling it the center. So now we need to find the value of p. So negative 2 is equal to 4p. So p, if you divide by 4, that's negative a half. 2 over 4 is 1 half. So this is the center. We need to go half units. Well, the graph opens downward, so we need to go down by a half and up by a half. So if you go down by a half, that's the focus, but it's too small to draw. The directrix, we know it's this line here. So the focus is going to be h comma k, but since we need to go down, it's minus p. So h is negative 1, k is 3, but we need to go down by a half, so we need to subtract 3 by 1 half. So 3 is basically 6 over 2. Minus a half, that's 5 over 2. As you can see, the focus is at 2.5. It's between 2 and 3. So I'm going to draw a little F here for the focus. The directrix, it's going to be y is equal to, since it's horizontal, it's going to be k plus p. We need to go up p units. So that's 3 plus 1 half, or 6 over 2 plus 1 over 2. So it's y is equal to 7 over 2. That's the directrix. Okay, so we have the general shape of the graph, but the hard part is choosing the values for x and y that we should pick. So if it's not in standard form, it's easier for you to plug in, well, I guess you have to pick which way is easier for you. But we need to plug in some values. You can choose to plug in values for x and solve for y, or you can plug in values for y and solve for x. It really depends on whichever you think is easier. What I'm going to do is I'm going to plug in a value for y and solve for x. Now my directrix is at 7 over 2. And the graph, the center, the y-coordinate is at 3. So the graph doesn't go past 3. It doesn't go past the vertex if it opens downward. So I can't choose any value that's greater than 3 for y. let's say if I choose 4. 4 minus 3 is 1. 1 times negative 2 is negative 2. And you can't square root a negative number. So I have to choose something that's less than 3. I already have the value for 3. When y is 3, x is negative 1. That's the vertex. So I need to choose something less than 3. But I want to choose a number where when I multiply it by negative 2, it's going to give me a perfect square. So I want to choose 1 for y. Because 1 minus 3 is negative 2, and negative 2 times this negative 2 in front is 4. And I can take the square root of 4. So if x plus 1 squared is equal to 4, x plus 1 is therefore equal to plus or minus 2. So it's equal to 2 and negative 2. If x plus 1 equals 2, if I subtract both sides by 1, I get x equals to 1. And for the other one, if I subtract 1 from negative 2, negative 2 minus 1, that's negative 3. Now I need to choose another point where I can get another perfect square. Perfect squares are like 4, 9, and 16. I already used 4. I don't want to use 9 because I need a fraction to get that. Well, actually, let me use 9. Let's see. I need to set y minus 3 equal to half of 9, which is 4.5, but negative 4.5. So if I add 3 to both sides, y is going to be equal to negative 1.5. I'm going to choose that for my y value. So if I plug in negative 1.5, I get negative 2 times negative 1.5 minus 3, which is negative 2 times negative 4.5. That's 9. So therefore, x plus 1 squared is equal to 9. And if you square root both sides, x plus 1 is equal to 3, which means 3 minus 1 is 2. And x plus 1 is equal to negative 3. Negative 3 minus 1 is negative 4. So that should be enough points for this particular example. So when x is 1, y is 1. So that's over here. And when x is negative 3, y is 1. So we can see the symmetry about this line here. When x is 2, y is negative 1.5, which is about there somewhere. And when x is negative 4, it's over here. So this is enough points to graph it. So now let's say if you're given these 4 equations. X squared plus 6x minus 4y plus 1 is equal to 0. And 4x squared minus 9y squared minus 16x plus 54y. Let's say that's equal to 0 as well. And then this one, 2x squared and the last one, so given these 4 equations, which one is a circle, which one is an ellipse, which one is a parabola, and which one is a hyperbola? Now the first thing I would look for is the parabola, if you have all 4 options. The parabola is the one that has an x squared but not a y squared, or it has a y squared but not an x squared. So here we see, I meant this to be a y squared, by the way. So here we have an x squared and a y squared, so that's not a parabola. X squared, y squared, not a parabola. x squared, y squared. This is the first one is the only one that doesn't have an x squared and a y squared. So this is the parabola. That's how you can distinguish it from the other three. Here's the x squared, but there's no y squared. Or there could be a y squared, but no x squared. So now, which one is the hyperbola? That's the next thing you want to look for. Now, the hyperbola has a positive x squared and a negative y squared, or vice versa. The ellipse and the circle, both x squared and y squareds are positive. So both of these are positive, both of those are positive. But notice this, we have positive x squared and negative y squared. The ellipse, the hyperbola has the minus sign. So whenever you see that, a positive x squared, negative y squared, or vice versa, it's a hyperbola. Now, to distinguish the circle from the ellipse, look at the coefficients of x squared and y squared. A circle is perfectly even. So if the coefficients are the same, it's a circle. If the coefficients are different, it's an ellipse. And that's how you can distinguish these four conic sections if it's not in standard form. So now, we're going to talk about how to put these equations in standard form. So let's start with a circle. So we had 2x squared plus 8x plus 2y squared plus 4y minus 6 is equal to 0. So the first thing you want to make sure is you want to group the x's and the y's together, which we already have that. So for the first two terms, let's factor out the GCF of the coefficient. So between 2 and 8, we can take out a 2. And so we're left with x squared plus 8x and leave a space. And between the next two terms, we can take out a 2 as well. So we have y squared plus 2y, leave a space. And then the negative 6, let's move it to the other side. Now we need to complete the square. Half, oh wait, this should be a 4. Not an 8, because that took away 2. So you want to take half of 4. Half of 4 is 2, and then square it. Half of 2 is 1, and then square it. That's how you complete the square. But now notice that we added 2 squared times 2 to the left side. 2 squared is 4 times 2 is 8. So we got to add 8 to the other side as well. 1 squared times 2 is 2, so let's add 2 as well. So now we can factor. It's going to be x plus whatever that sign is. And then this number, before you square it, x plus 2, and then squared. To factor the next term, it's going to be whatever this variable is, y, plus 1 squared. Eight plus 2 is 10. 10 plus 6, that's 16. So now, when you have a circle, you got to get rid of these coefficients. So we're going to divide everything by 2. So our final answer is x plus 2 squared plus y plus 1 squared. The 2's cancel. And then 16 divided by 2 is 8. So now it's in standard form. The center of the circle is negative 2, 1, and the radius is the square root of 8. So that's how you can write the equation of a circle in standard form. And then if you want to, you can graph it if needed. So now let's move on to the ellipse. So we had 4x squared plus 25y squared minus 24x plus 100y plus 36 is equal to 0. So first, let's move the x's and the y's together. So 4x squared minus 24x plus 25y squared plus 100y. And let's move the 36 to the other side. So let's factor out a 4 from the first two terms. We want x squared to have a coefficient of 1. So it's x squared, and then negative 24x divided by 4, that's negative 6x. And let's leave a space. Let's factor out 25. 100y divided by 25 is 4y. Leave a space. And then let's complete the square. So half of 6 is 3, ignore the negative sign, and then square it. Half of 4 is 2, so that's 2 squared. So 3 squared is 9 times 4, that's 36. So we got to add 36 to this side. 2 squared is 4 times 25 is 100. So let's add 100 to that side. So now let's factor. It's going to be 4, whatever this variable is, x minus this number squared, and then plus 25, this variable y, plus this number 2 squared. Negative 36 and 36, they cancel, so we're just left with 100. Now for ellipses and hyperbolas, this number has to be a 1. So divide by what you see there. So we're going to divide both sides by 100. So we have x minus 3 squared. So 4 over 100 divided backwards. 100 divided by 4 is 25. But since you divide it backwards, 25 goes in the bottom. 100 divided by 25 is 4. And 100 divided by 100 is 1. So now we have the equation of the ellipse in standard form. As we can see, the center of the ellipse is 3, negative 2. And a is the larger of the two. A squared is 25, so that means a is 5. B squared is 4, so b is 2. And keep in mind, for an ellipse, it's c squared equals a squared minus b squared, if you want to find the foci. So now let's try this one, the hyperbola. 4x squared minus 9y squared minus 16x plus 54y minus 101 equals 0. So let's move the x's and y's together. So we have 4x squared minus 16x, and then minus 9y squared plus 54y. And let's move the 101 to the other side. So now let's factor out a 4. So 4x squared divided by 4 is x squared. Negative 16x divided by 4 is negative 4x. Leave a space. Next, let's factor out negative 9. 54 divided by negative 9 is negative 6. And now let's complete this square. Half of 4 is 2, so let's add 2 squared. Half of 6 is 3, so we're going to add 3 squared. Now 2 squared is 4 times 4. We need to add 16 to this side. 3 squared is 9 times negative 9, so that's negative 81. So let's add negative 81 to that side. So now let's factor. It's going to be 4 times x minus 2 squared, and then minus 9 times y minus 3 squared. So 101 minus 81, that's 20. 20 plus 16 is 36. Now we need the 36 to be a 1 for a hyperbola. So let's divide every term by 36. So if we divide it backwards, 36 divided by 4 is 9. And 36 divided by 9 is 4. And this we get 1. So the center for the hyperbola, it's 2 comma 3. Whatever is positive, that's a squared. And therefore this is b squared. Now for the last one, this is a parabola, and we want to put it in a form where it's like this: x minus h squared is equal to 4p y minus k. So all the x's we want to move to the left side, and everything else let's move it to the right side. So x squared plus 6x is equal to negative 4y becomes positive 4y when you move it from left to right, and the positive 1 becomes negative 1. So now let's complete the square. Half of 6 is 3, and so we need to add 3 squared to the left. And whatever you add to the left side, add to the right side. So 3 squared is 9. So to factor the left side, it's going to be x plus this number before you square it. And then over here we have 4y. Negative 1 plus 9 is 8. So all we got to do now is factor out a 4 from the right side. So it's 4y plus 2. And now the parabola is in standard form. The vertex is -3 comma -2, and this number is equal to 4p, so p is 1. And that's basically it. So let's review the general equations for every conic section. So starting with a circle, keep in mind that your general equation is x minus h squared plus y minus k squared, which equals r squared. And the center is hk. So once you have the center, let's say this is h, this is k. You need to go r units to the right, r units to the left, up r, down r, and then graph the circle. Now, for an ellipse, if you have x minus h squared over a squared plus y minus k squared over b squared equals 1. So remember, a is the bigger one. A is greater than b. So what's going to happen is, let's assume the center is the origin. You're going to have a graph that looks like this. So if this is the center, this is therefore a. That's negative a. This is b. This is negative b. Just remember, these are the endpoints of the major axis. So those are the vertices, and these are the endpoints of the minor axis. And your foci is along the major axis, which is somewhere over here. So your vertices for this particular example it's h plus or minus a comma k, and for your foci it's h plus or minus c comma k. And the last thing that you need to know is to find c. It's c squared is equal to a squared minus b squared for an ellipse. And if you have the other version where you have x minus h squared, but let's say b is under x, and y minus k squared, where a is under y, this ellipse, it's going to be elongated. It's like a vertical ellipse. It's going to look like this. So this is a, this is negative a. This is negative b, that's b. So now your foci, to find it, it's going to be h comma k plus or minus c. So you add and subtract c to the y coordinate instead of the x. And your vertices are h comma k plus or minus a. So the major axis is vertical, the minor axis is horizontal. Now keep in mind, the length of the major axis is 2a. The length of the minor axis is 2b. So to review, for a hyperbola, it can be x minus h squared over a squared minus y minus k squared over b squared equals 1. Or it can be y minus k squared over a squared and x minus h squared over b squared. So keep in mind, for a hyperbola, a always come in front. So b could be bigger than a, or a could be bigger than b. It doesn't matter. And c squared, to find the foci, is a squared plus b squared rather than a squared minus b squared. So for this example, it's going to open this way. So let's say if we drew the box. So this is a, that's negative a, this is a. Here this is b, and that's negative b. So for this particular example, the asymptotes is y minus k, which is equal to rise over run. Rise is b, run is a, so plus or minus b over a, x minus h. And the vertices for this equation, it's h plus or minus a comma k. Now for this one, the graph opens this way. I'm not going to draw the box though, but you know how it is. You know how to do it. But this time the vertices is going to be h comma k plus or minus a, and the asymptotes will be y minus k is equal to, this time a over b, so plus or minus a over b x minus h. And that's really what you need for a hyperbola. Those are the main equations. Oh, I forgot the foci. The foci is going to be h k plus or minus c for this example, and for this one it's going to be h plus or minus c comma k. So just so you know, the foci is where it opens towards. So the foci is over here, and in this example it's over here. And lastly, what we have is the parabola. So for this one, here we have x is equal to y squared. So it can open to the right, or it can open to the left. So your focus is always on the interior towards where it opens, and your directrix is here. So for this example, we know that the vertex is h comma k. So the focus is p units from the vertex, so it's h plus p comma k. And for this example, the focus is h minus p comma k. The directrix is x is equal to h minus p, and here it's x is equal to h plus p. Now for the other one, it's x minus h squared is equal to 4p y minus k. So for y equals x squared, it can open up or it can open down. Here p is positive, p is negative. For this one, when it opens to the right, p is positive. When it opens to the left, p is negative. So the focus is somewhere over here, and the directrix is horizontal this time. So the focus is going to be h comma k plus p, and for this example it's h comma k minus p. The directrix is horizontal, so it's y is equal to k plus p, and here it's y is equal to k minus p. So that's all the equations that you need for conic sections. So basically that's the end of this video. So thanks for watching and have a great day.